Hello everyone. So let's continue with the problems where we left in the previous video. So here under substitution, when we have a linear format, that's how the problems we were proceeding. At the same time, let me start with the next one. So let me mark it as one. So here integrate, they are giving sine 4x divided by sine 2x dx. Okay, let me just recall the formula which you guys already know under trigonometry. We have sine 2x is equal to 2 sine x cos x. Okay, so here if I have 2, then I'm getting 1 here and here also 1. If I have sine 4x, in that case, I would be getting 2 sine times of 2x cos of 2x. It is nothing but sine of 2 times of 2x. That is what has happened. That's what is equal to this one. If you have sine x, in that case, you would be getting 2 times sine of x by 2 cos of x by 2. Half of it. Here 1 is there means half of 1. Here 2 is there means half of 2. So based on that only, it is split down. Now here, let's go with the problem now. I'm considering this as I is equal to, here sine 4x, I can write the sine 4x as 2 times of sine 2x cos 2x. Sine 2x cos 2x divided by, no need to split the denominator. Since I find my numerator already in the format of sine 2x, both of them would be getting cancelled. 2 is a constant which comes out and we have cos 2x to integrate. So what would be the integration of cos 2x? Obviously, sine 2x I would be getting. But what is the coefficient of x? Is 2. So that's the reason divided by 2 plus c. 2 and 2 gets cancelled and you would be getting sine 2x plus c. Now we have a similar problem with the denominator alone getting changed. Sine 4x divided by cos 2x dx. Now the problem goes in the same way. Obviously, I'm not going to expand my cos 2x and change it to a complex one. I would be just 2 times sine 2x cos 2x divided by cos 2x dx. Then 2x gets cancelled. 2 times integral sine 2x dx. When I integrate sine 2x, I would be getting negative of 2 by 2 cos 2x plus c. So which is nothing but 2 and 2 gets cancelled, minus cos 2x plus c. Okay, a similar approach. Now the next one. We would be just improvising our problem little by little. So now just observe this question. It is one of the NCERT problem. Sine to the power 8x minus cos to the power 8x divided by 1 minus 2 sine square x cos square x dx. Okay. What has to be done here? Very simple. We know a square minus b square as a plus b into a minus b. Now, if I have a square, instead of a square, if I have a power 4 minus b power 4, I would be writing it as a square plus b square into a square minus b square. Okay, if I have, instead of 4, if I have 8, the power is a to the power 8 minus b to the power 8, I would be writing it as a to the power 4 plus b to the power 4 into a to the power 4 minus b to the power 4. This is how I split it. So now in the same way, I'm going to split the numerator now. So now here I would be getting I is equal to, so is equal to integral. I would be having sine power 4x plus cos power 4x into sine power 4x minus cos power 4x divided by, I need to do some tinkering work even in my denominator. The one we know 1 in trigonometry is equal to sine square x plus cos square x. Okay, but the denominator power is square. The numerator power is 4. I need to bring it equal to 4. That means I need to square something. So what I would be doing, I would go ahead sine square x plus cos square x whole square. That's what I'm going to do. Then minus 2 sine square x cos square x. That's it. Now here, now what would happen? Like if we go ahead and expand it, the denominator part, let's see the change in denominator. If I go ahead and expand it, I would be getting here sine to the power 4x. This part I'm expanding. Sine to the power 4x plus cos to the power 4x plus 2 sine square x cos square x. And then we have minus 2, which is there here. That part also I'm including. Sine square x cos square x. Both of them would be getting cancelled and I would be left out with sine power 4x plus cos power 4x. What is this equal to? 1, obviously. And then let's go with our, okay, this one. Here we have sine power 4x numerator plus cos power 4x here. And then we have sine power 4x minus cos power 4x. Obviously, these two would be cancelled because both are same. And then we have been left out with integral sine power 4x minus cos power 4x dx. Now, what is this all about? It's very quite simple if you just take a negative out. We learned cos 2x as cos square x minus sine square x. It is of the same format, right? So now here what we are going to do here is, I'm going to take a negative out. If I take a negative common from here, it would be getting changed as cos power 4x minus sine power 4x. Okay. But still, these two are not same. The power is different. Yeah. So now here, it is in the format of a square minus b square. So now here, let me do the change again. So now here, I would be having cos square x plus sine square x into cos square x minus sine square x based on a square minus b square, the identity which we used here. Okay, dx. Now what is our sine square x plus cos square x or cos square x plus sine square x? Which is 1. We have cos square x minus sine square x dx. Done. So now after this part is equal to cos 2x. So now write that minus of integral. We have cos 2x dx. So now when I integrate this, I would be getting minus 1 by 2 sine 2x plus c. That's it. Got out. And then we would move on to one more trigonometric problem under integration. It's just the idea which we have based on those formulas. If we are knowing all those things, then we would be able to solve it very quickly. So now here, integral root of 1 minus or plus sin x dx. And they are saying very clearly, they have given me restriction very clearly, x is greater than 0, but x is less than pi by 2. This has been given to me. Now, how will I proceed with this problem? Let me consider I as is equal to root of 1 minus or plus sin x. Now, what is our 1 is equal to? 1 is nothing but sine squared plus cos squared. Okay. But before we do that, we need to check when I need to remove a root, I need it in this format so that the root would be getting cancelled. But do I have in that format? Okay. If I'm introducing 1 as sine square plus cos square, sine square plus cos square. Okay, that's done. Then, but I have sin x. I don't have plus 2 sine cos, so I don't have that. So what I would be doing here, the sin x which I have, that part I will do the change. What I will do, I would bring sine in the format of sine 2 theta. In that format, I'm going to bring. Okay, sine x. So what I will do, I will introduce sine x by 2 cos x by 2. That is how I wanted to bring. So see here, in the beginning, sine x is nothing but 2 sine x by 2 cos x by 2. I told that in the beginning. So based on that, I will do the change here. So what I'm going to do, root of minus or plus, I would be writing 2 times of sine x by 2 cos x by 2. And then 1 I would be replacing it as not just sine square x and cos square x because that's not going to help my requirement. I will make it the 1 as sine square x by 2 plus cos square x by 2. Now, what is this I is equal to now? The entire thing would be getting changed up. See, very easily I would be removing my root. This is gonna be sine of or cos, whatever you wanted to put. I will put it as sine x by 2 minus or plus cos x by 2 the whole square. Now what happened? This and this square root went away. Now once the square root goes away, I can easily integrate. Since because of the square root, I was unable to integrate, though I had an integration of 1, though I had an integration of sine x, the square root was stopping me from doing that. So now, since I got that, I remove my square root. Now very easily, I can go ahead with my integration. So now here, integral sine x by 2 dx minus or plus integral cos x by 2 dx. Now, when I integrate sine x by 2, what I would be getting is minus cos x by 2. What is the coefficient of x here? 1 by 2. So, 1 divided by 1 by 2, it's going to be 2. So, done with this part. And then here, what I would be having here is minus or plus I would be having sine x by 2 divided, um, into, I would be getting 1 by 1 by 2, which is nothing but 2. That's it. Now here, something is peculiar. I don't want this minus or plus. I want plus or minus. So what I'm gonna do, I'm gonna remove this negative common here. When I do that, I would be getting it as I would be getting it as, and even 2 also I can take common, cos x by 2. And then here when I take negative common, it becomes plus or minus sine x by 2 plus c. That's it. If you don't want this plus or minus in the beginning, you could have done a change here actually. You could have changed here as the formula could have been changed as cos x by 2 plus or minus this negative sign if you don't want in that case. You could have changed it as cos x by 2 minus or plus sine x by 2. If we would have done in that way, you would have you wouldn't have got this negative here. That's not a problem. Whatever way you get, both the answers are correct. And then this under integration of indefinite integrals, under substitution, we have that choice. Now let's go on with the next problem, the fifth one. Hope you remember the rationalizing which we did earlier. The similar approach we have here. Integrate 1 divided by root of 3x plus 4 minus root of 3x plus 1 dx. Obviously, I would be considering this as I is equal to, that's how we begin with. And now see here, I have root minus another root. I need to remove the root, that's the thing, in the denominator. How to do that? Rationalizing would work. So now what I would be doing here is, I would consider this as it is, root of 3x plus 4 minus root of 3x plus 1. I'm going to multiply with the same terms, whatever I have, but with a positive sign in between. So 3x plus 1 and multiply as well as I'm going to divide by the same thing. 3x plus 4 plus root of 3x minus 1. Sorry, plus 1. Now, my denominator would be without a root 1 because I'm having a minus b into a plus b, which is going to be a square minus b square. So that is like root a plus root b into root a minus root b. So what is happening? Root base is same. The powers I'm going to add it up. So I would be getting it as a to the power 1 minus b to the power half plus half is going to be 1. I would be getting a minus b. The same thing is going to happen here. I'm going to get it as 3x plus 4. The whole square means the root will go away. And then minus 3x plus 1 root of 3x plus 4 plus root of 3x plus 1 dx. Now what I would be having here is 3x plus 4 minus 3x minus 1 plus 3x minus 3x gets cancelled and you have the numerator as root of 3x plus 4 plus root of 3x plus 1 dx. Now here integral 4 minus 1 is gonna be 3 and we have root of 3x. We can just integrate after this, no need to worry at all. We know this integration for which we have done it is in the format of linear format. So 1 by 3 integral 3x plus 4 whole to the power half dx and then plus 1 by 3 integral 3x plus 1 whole to the power half dx. So after integration, what we would be getting, I'm writing it directly. So you would be getting it as 2 by 27. Let me take it totally common and let me write it as it's gonna be 3x plus 4 whole to the power 3 by 2 and then plus 3x plus 1 whole to the power 3 by 2 plus 6. Since we have done similar problem a lot of times, so that's the reason I wrote it directly. Okay, I think you would have understood by now. So this pattern. So based on this pattern, only one last problem let me do and wind up with this type so that we can move with the next type in the next video. So this was problem number 5, and we will go with the problem number 6. Integrate a to the power 1 plus x plus 4 to the power 1 minus x divided by 2 to the power x dx. Wow, I have something in the powers. How to do this problem? A very simple. Try to make everything with a common base, both in the numerator as well as in the denominator. After that, we can proceed very easily. So now let me consider this to be equal to I. And now here I have 8. 8 is nothing but 2 cubes. So I'm going to write just 2 to the power 3 plus 3x, or I can write as 3x plus 3. And then plus 4 is nothing but 2 squared. I can write it as 2 to the power 2 minus 2x, because 2 squared is getting multiplied with 1 minus x, 2 is getting multiplied. And then I have 2 to the power x now dx. Now after this, what I would be doing? I would be splitting them. See here, I would be writing it as 2 to the power 3x plus 3 divided by 2 to the power x dx, and then plus 2 to the power 2 minus 2x divided by 2 to the power x dx. Now when the base is same and when it is getting divided, I would be going ahead with my subtraction of my powers. So this is how it would be. What I meant is a by m and then a by n, then it is going to be a to the power m minus n. That's how it would happen. So here in the same way, 2 to the power 2 minus 2x minus x dx. Now in that case, here I would be getting 2 to the power 2x plus 3 dx. And then here I would be getting it as integral 2 to the power 2 minus 3x dx. Now let's proceed with the integration directly. So what I would be getting here is 2 to the power 2x plus 3 plus 3, okay, divided by, you would be having 2 log 2. And then here I would be having plus 2 to the power 2 minus 3x divided by minus 3 log 2. That's it. So here, so it's gonna be 3 log 2 and then this one log 2. I think we have done with it. One more thing we can do here. That's it. Like even 2 is having a common here. So what I'm gonna do, 2 to the power 2x plus 3 and then minus 1 divided by log 2. Why did I do that? Because here I have a base 2 and here also I have base 2. And then plus 2 to the power 2 minus 3x. And this plus, let me make it as a minus here. Minus 3 log 2. That would work. Plus c. So here I would be having finally 2 to the all the possible ways I'm getting my answer in an elegant way. I don't want 2 when I have a numerator 2, base is there. Something is common. Let me bring it in the standard form. That would be a better. 3 log 2 plus c. That's it. With this, the problem gets over. We will do type 2 problems in the next video. Thank you, guys.